Well, greetings from Nani Notes. And here we are looking at squares again. We already had one video on this, but this one, I was inspired by The Little Prince, my favorite book from growing up. And I was just thinking of squares from the inside, squares from the outside. Well, some of you get that. But okay, let's look at the first part of this, this lesson, 1.7, constructing squares. These are the beginning pages, 45, starting out with this. Now I just got to comment on this because I had fun with this in class. Um, you're given these four figures A, B, C, D, and your students are supposed to say, well, which one doesn't belong, and they're all going to pick something different. Of course, someone picks A and says it's the only one that's shaded, only shaded one. Okay, yeah, I'll buy that. It's not very profound, but okay. And then somebody is going to look at, someone's going to look at this B and say, well, it's the only one not equilateral. And I said, oh, okay, that's good. And, I'm saving this one for a while. Well, okay, I'm looking at this one, going right along with that. You can say, well, hang on a second. I've got this thing right here, and I say, well, hey, that's the only one. The only one not equiangular. Ooh, I thought I was onto something. And finally, over here, you're looking to say, okay, well, what about D? Who picked D? And then certainly someone would say, hey, that's the only one that's not a quadrilateral. But then a student was picking out C, and I couldn't understand what she was saying. And finally, I says, my God, she's right. The most interesting comment on C was the only one perimeter not equal to, oh, do I have a not equal sign? Yeah, I do. Come on. Come on, Sketchpad. Yeah, perimeter not equal to 8. Oh, I can't believe I missed that. Check it out. It all works out. So, to each their own, and I'm glad that you all had fun looking and picking out something different and justifying your answer. All right, but this video is really about constructing a square. And I've got to go through this just so we can say, this is how we construct a square, with a given side AB. And we're going to say, all right, well, we're going to do the old, we're going to do the compass thing. I'm going to gap it from A to B, give it a swing, and that's going to generate those 2 points that are equidistant. Well, we already have point B, that are equidistant from A. This is the perpendicular, the construction for a perpendicular through a point, to a line through a point on the line. Say that 3 times fast. And of course, you take the other compass, you put it on one of those intersections, you gap it to the other, which happens to be B. And this is what we have affectionately called the egg construction. We're going to flip the compass around and gap it that way. And that's certainly going to give us enough to go by, and we can construct our perpendicular line, because we've got 1, 2 points that are equidistant, or 1, 2 points to determine a unique segment line array. Gosh, I'm getting tongue-tied today. Sorry about that. All right, well, let's clean this up, and I'm just going to refresh your memory that that's we call the egg construction, but our textbook likes to use full circles, and full circles are legit too. If you did the complete circle, it would look like that. And I'm going to get rid of these compasses just to make life easier. And honestly, on this first compass, it would have behooved you to come up here too, so you have both those intersections with this perpendicular line. Now, I was kind of not crazy about these full circles, but I gotta say, from a mechanical point of view, it does give you 3 points, which should be guaranteed to be collinear, but it gives you mechanically a better position to have these two far apart. So that's the construction that we've been doing. And then in your textbook, they said, well, okay, well, repeat that construction. So do these three circles or compass swings centered on B this time, and you can gap back to A. Now, when you do that, of course, that's your first, second, and third in either order. And it might look confusing, but you say, hey, I got this. I got this. And let me scoot that up there just so you can see the arrows. And you're saying, well, all right, then I can't, for some reason, your author of your textbook wants you to construct, do a perpendicular to this line going through this point, but, come on, you've already got the square. And you can see that because you got a square there. Now, you also have a square here. So you've got your choice. You've got two squares, square one, square two. But I want to point something out. You didn't need to do this complete construction because you could have just, let's say you're going back here. You could have just done this. Gap your compass right there. Grasshopper. Because we know that a square is equilateral, right? Okay, and we're just going to make a full circle because it's fun. And let's gap this and spin it this way. And you say, wait a minute. I only needed one extra point because that's got to be C right there. So right away, I've got my square. See it? Bingo. And you save, and I guess you're doing one less compass swing. That's pretty good, isn't it? Excellent. All right, let's go to the next page. And we're going to construct polygons from the inside. And this time I'm starting with a square ABCD, and I'm starting with a diagonal BD. And it's asking me to do this. Take this compass swing and gap it here and make a circle. Now, why are we doing this? I don't know. But we're going to make a circle there. And then we're going to take our compass. This next step is asking us to do this. And you say, all right, well, if we made a complete circle, it would look like that. And you're probably saying, well, gosh, what is going on here? I mean, okay, I guess that was the other part. We're going to draw the other diagonal. That's what I'm forgetting. I suppose I could have read this. And they say, what's the relationship with that diagonal? And I guess they want you to say, heck, this looks like the perpendicular bisector construction for AC, because it does look that way. Of course, it was totally unnecessary to do that if your objective was to find this magic point right here in the middle. We'll call it E, because E tells us something about these points. If I were to put the needle on E and gap it to any one of those vertices, I would see right away that this polygon is inscribed in a circle, which is really cool. Now let me clean this up a little bit. I'm going to get rid of some of this stuff. And again, clean that up and hide that circle. The fact is, we could have just drawn the diagonals. That part about the perpendicular bisector was just so you could see that. But honestly, you just take if you're starting with a square, a known square, the diagonals are going to intersect like this. The diagonals are going to be perpendicular and they're going to be congruent. And that means that E is equidistant from the four vertices. And this compass, again, is going to trace a circle around circles from, all right, we're going to draw circles from the inside, or squares from the inside. Okay, enough of the little prints. And that's kind of fun. Again, knowing that is a I guess we could say it's cyclic too, a cyclic quadrilateral, but it is inscribed polygon. Now, we're going to construct the next page, 48, asks us to construct a square inscribed in a circle, starting with the circle and its center. That's kind of key. Now, I've just said I'm going to name it SQRE because the first thing I'm going to do is I'm going to draw a ray or a line, but I'm picking a random point and I'm going through the center and I'm going to pierce through on this side. And I asked the class, what letter is it going to be? SQRE, SQRE. And some people said the Q, and a couple students said, aha, no, that's got to be point R, like a good pirate. It's got to be R because you see they are non-adjacent sides. When you're naming the convention of naming a polygon, you must go around the figure. And S and R are across each other on a diagonal. So let's do this. Oops, well, that's where I jump into it. Hey, wait a minute. Okay, I did that. Identify the intersection R. I really kind of messed this up. And we're going to construct this circle. Well, you don't need to see that tracing, but you see this. I'm going to make a circle from S passing through R, and then I'm going to construct R through S. Oh, yeah. Boy, who's my editor? So, of course, you've seen this shape a bunch of times. Looks like the old CBS shape. Are they even still around? And now we can construct the perpendicular bisector. So that's the perpendicular bisector construction, and you're saying, oh, yeah. Hang on, I'll put that full circle in there in case somebody really wants to see it. Snap. And we do that perpendicular bisector construction, and that is going to intersect our circle at 2 points, our original circle. And, it's arbitrary here. So I said, well, what goes here, the Q or the R? They're really either one. But I'm going to put the Q there, and I'll put the E here. Sorry, the Q or the E. And because I go around the figure, SQRE. And then what do? I draw it like that. Beautiful. Something didn't show up here. What doggone it. But there you go. I started with a circle, and I generated a square. That was a fun construction. And there you go. Squares, circles, and squares from the inside, the outside. I've got to read the book again. Now, before I let you go, I just want to remind you of one thing. I mentioned this in the other video, but all the regular polygons can be inscribed in a square. It's inscribed in a circle. All the regular polygons can. Now, it does not make any shape that is inscribed in a polygon, inscribed in a circle, does not have to be regular. But all the regular ones are inscribed in a circle. But there's a property that I hope we explore later on, maybe in the trig section of this class. But that's the radius of the circle. So I made it red. It is also the radius of the polygon. It's a little vocabulary that I haven't seen in this text yet. But maybe we'll circle back to this again when we're doing the trig section, because here's a word I know you probably haven't seen, and that's the apothem. And the apothem is the distance from the center of this circle to the midpoint of each side. And that's going to generate this really cool right triangle that's going to give us a lot of fun relationships. Now that's going to be true for every one of the regular polygons. And the observation was made in class. We increase the number of sides, and these circles start to approach each other. They get closer and closer. And you can see, look at this, the difference between these two circles. And that's only 10 sides. That's a decagon, a regular decagon. So hats off to the Greeks for using a regular 24gon to estimate the area of a circle. Amazing. And I guess we're going to call it quits right there. Before I mess up again, and I'm just going to post this, and I'll see you all in class. Hey, and bring your Chromebooks, and we got a quiz. All right, 90 notes out.